Okay, let's look at a word problem involving quadratic. So the manager of B's bike shop knows the cost of selling bikes is this. So $20 per bike, $60 flat rate. The revenue for selling X bikes is this. X squared, revenue equals X squared minus 8X. Algebraically find the break-even value of X. So break even could be, you have profit equals revenue minus cost. Break even is where that is equal to 0. But they're also even saying here, break even occurs when the cost is equal to the revenue. So if you have cost equals to revenue, so let's just start out like that. Cost is 20x plus 60. And the revenue is x squared minus 8x. So we're setting them first equal to each other. Now we want to solve for x. How are we going to solve for x? It's quadratic, so we have to set it equal to 0. So I'm going to subtract 20x and subtract 60. So now we get 0 equals x squared minus 28x minus 60. How can I solve that? I need to solve by equal to, you want to factor, right? Factor 0 equals x times x gives us x squared. Give me two numbers that multiply to 60 that add to 28. 30 and 2? Oh, 30 and 2. One of them has to be negative. Good job. Negative 30, positive 2. Now what would x equal? Negative 2 and positive 30. Interpret your results in a complete sentence. Now, can you sell negative 2 bikes? No. So this is where we would have the idea of an extraneous solution. Since you can't sell negative 2 bikes, we would exclude, we call this extraneous, okay? And we would keep the positive 30. So now tell me the sentence answer. They will break even if they sell 30 bikes, right? Isn't that what we're trying to find here? Selling 30 bikes. Use your calculator to graphing Y1 and Y2. So here's the cost, here's the revenue. Scale and label the axes so that you will be able to plot the break-even point. Use your intersect feature or on the table to calculate. So what we want to do right here, this is the line, y, this is the cost, y equals 20x plus 60. So we're going to our graphing calculator. Oops, y equals, clear out what you have, and we are going to put in 20x plus 60. And then the other one, the parabola, is x squared minus 8x. So we have x squared minus 8x. And if we graph, we will see these shapes, and they want to know what's the scale. So we know that they're breaking even here. They're actually meeting at these two places. Can anybody guess what x value are we at right here? That would have to be negative 2, right? Because those were the two solutions we got, where they break even, where they actually cross each other, where they intersect. And this has to be x equals 30. So in order to be able to see this, we're going to have to play around with the window. So we know that this is going over more. It has to at least go over to 30. Does everybody understand where I'm getting these two x values from? Okay, so let's go to the window. Yes, the revenue minus the cost. Okay, so now I want my x values to go. How far over should I have my x values go? This is probably 10, 20, 30, 40, right? Let's go over to 50, how about? We can overshoot it a little bit. And then we definitely need our profit to go up. We definitely need our amounts. This is the money here, right? We need that to go up higher. So how much does it cost me to produce 30 bikes? What do you guys think this number is right here for Y? If I produce 30 bikes, how would I figure out the cost? Well, here's my cost. Here's my revenue. So 30, okay, 30 times 20 plus 60, 660. So this is right here, at least 660. So how far do you want my Y maximum to go up, do you think? Maybe at least 1,000. I would say at least 1,000, right? Okay, now let's graph it. I'm getting closer to seeing this situation here. It doesn't look exactly the same. Similar-ish. Okay, so did I get this right? The cost. Now we can actually also look at the table of values. So on the table, I put in Y1. This was my revenue. I actually switched my Y1 and my Y2. Sorry about that. So for -2 bikes, -2 bikes, see how the cost and the revenue is the same, both 20? If I scroll up here to 30, I will find out what my cost and my revenue are, and they should be exactly the same. So there are faster ways to get here, but I'm just scrolling one by one. Okay, 3660. So how could what scale could I use? This point right here is 3660. This point over here is -220. Oh, 200, 400, 600. That didn't quite get me there. So maybe 300, 300, 600. Oh, maybe this scale is maybe a little wonky anyway. All right. Well, let's skip the scaling part, but this is right here, 660. Because that definitely can't be counting by 300 because that would be 900. State the break-even value of x by looking at your graph. How does this result compare to the algebraic work you did? So here, the break-even point is here and here. State the break-even point would be what? Point is 30 bikes. The revenue and cost is 660. So if you had done the check, remember how I was talking about doing a check earlier? If you plug 30 in to your original equations, that's how I got the 660 besides looking at the table. So the revenue and the cost would be the same. If I do a check, that's going to show me what the cost and the revenue was, right? Because if we plug in 30, we get that. If we plug in 30 here, we would also get 660. Okay, any questions about this? And by the way, the profit equation would just be this right here, x squared minus 28x minus 60. If we set that equal to 0, that's also a break even. So when the profit equals 0 is a break even, but that's because your cost and your revenue are the same. Any questions on this before we move on to the next one?